Hello scholars, today you're going to be learning Skill 8, Factoring Trinomials. Let's dig in. Our objectives today are to learn how to factor trinomials, find the greatest common factor of a function, and find the roots or zeros of a function. If we are going too fast or you need to pause, feel free to rewind or pause this video at any time. So when we talk about factoring, we're talking about taking pieces of an expression or a function and using those pieces to make the function again. Essentially what I'm saying is we're going to take small pieces of something, and then when we put it back together, kind of like a puzzle, it'll give us the answer. So what are factors? Factors are pieces of a quantity that you can multiply to get your original quantity. For example, if we take 18, we are going to look at the pieces of 18 that we can multiply back together to get 18. So we can use 1 and 18, 2 and 9, or 3 and 6. Likewise, if we look at 4x minus 16, we can see that if we take a 4 outside of 4x and 16, we will have 4 times x minus 4. We know this is true because if we multiply it back in, we get our original problem. So how many factors do you think this expression has? Well, if we look at all the pieces that are being multiplied, we have an x, we have an x minus 3, and we have an x plus 2. That means that we have factors. If we look at example 4 and we try to look at the factors, we're going to come up with a pretty interesting solution. We know that x is being multiplied here and a 2x is being multiplied. So you might be tempted to think that is all the factors. But if we hang on a second, we'll see that there might be more. So the steps to factoring a quadratic trinomial expression are different than the ones that we used with skill 7. We do still use factored by grouping, but we are going to need to find our greatest common factor and our ACB tree, which is a new concept that we're going to learn today. So if we take our previous example of x squared minus 2x minus 3 and we work it through, we'll see what we get. So the greatest common factor of x squared minus 2x minus 3 is just 1. We don't really have anything that's being multiplied across all of those numbers that we can pull out. Now our ACB tree is a new concept that we're going to use to add another term in so that we can factor by grouping. And when I say ACB tree, what I'm referring to is our standard form, our ax squared plus bx plus c. As you can see, if we write our formula in, we'll get x squared minus 2x minus 3, and we can find our a, our b, and our c. Our a is 1 for this instance. And what we're going to do is we're going to take our a times our c. So our 1 times our negative 3, that's going to give us negative 3. And we're going to find the factors of negative 3 that add to b. Remember, our b is negative 2. So we want the factors of negative 3 that add to negative 2. The factors of 3 are negative 1 and 3, and positive 1 and negative 3. Well, if we add 1 and we add a negative 3 to it, we will get a negative 2. So that is the numbers that we're going to use. We're going to separate our 2x into these two parts so that we now have 4 terms. As you can see, we added our terms in. We have x squared plus x minus 3x minus 3. And if we add those terms together, we will get our x squared minus 2x plus 3 back. So we know that we still have the same equation. But now we have 4 terms, so we can group them. So we're going to group our left side and our right side. I'll put that negative side inside, and then we're going to look for something that we can take out both sides so that the insides are the same. So we're going to take our x out from the left. It's going to give us x plus 1. You take a negative 3 out from the right side, and it'll give us x plus 1. Then we can group them, which will give us x minus 3 times x plus 1. And we know we factored it correctly because if we multiply it back out, we should get x squared minus 2x minus 3. I'm going to give you guys a second to multiply that back out, and then I'll show you the answer. So we can see that once we distribute our x minus 3 over, we get a x squared minus 3x plus x minus 3, which will simplify to x squared minus 2x minus 3. Now, if we want to do example 6, we're going to do our first step, which is look for a common factor. I can see that 6x squared minus 3x and minus 18 all share a 3, which will give us a 3 times 2x squared minus x minus 6. Next we're going to do our ACB tree, and I'm going to let you guys work on that, and then I will show the work. Just remember that we're looking for two factors, a and c, that multiply together and then add to b. So as we work through this, our a times c is going to give us negative 12. And I'm looking for the factors of negative 12 that add to our b, and our b is negative 1, because we only care about what is inside of our parentheses right now. So our factors of 12 are 1 times negative 12, 2 times negative 6, 3 times negative 4, and then we could keep going, but I see here that 3 times a negative 4 equals 12, and 3 plus a negative 4 gives me a negative 1. So I'm going to use those. I'm going to rewrite my formula. 3 times 2x squared. And now I'm going to replace this negative x with minus 4x. Oh my Lanta. Minus 4x plus 3x minus 6. Okay? And what I'm going to look for is a way to remove something from these insides so that they match. So the next step is going to be, I'm going to take out a 2x. That's going to give me 2x times x minus 2. And over here, I'm going to take out a 3, and that's going to give me plus 3, x minus 2. Now I can regroup these. I can write 2x plus 3, x minus 2, and multiply them together. I can't forget to bring my 3 down. And when I multiply these back out, I should get 6x squared minus 3x plus 18. I'm going to let you guys work that out, and then I will show you my work. Okay, as you can see, when I distributed my 3, I got 6x plus 9. And then I took my 6x plus 9 and distributed it onto my x minus 2. And what I got was 6x squared minus 12x plus 9x minus 18. And when I combined my like terms, I got 6x squared minus 3x minus 18. When we consider our greatest common factors, we're looking for the biggest piece that we can take out of all of our terms. So in this example, I see that there is an x in every single term, so I know that I can take that out. I also see that 2 is a factor of every single term here, so I can also take that out. So we're going to take out a 2x and see what that gives us. I'm going to give you guys a few seconds to think about what that would mean. Okay, so we can see that if we take a 2x out, if we factor out a 2x of this example 7, we're going to be left with x squared minus 6x plus 5. And we know that because if we put our 2x back in, we will get 2x cubed minus 12x squared plus 10x. So from here, we're going to need to do our ACB tree. I'm going to let you guys do your ACB tree on your own, and then I will fill it out. Okay, so the factors of a and c are 1 and 5. When we multiply those together, we have 5. And we're looking for b, which is negative 6. So we're looking for one factor of 5 that adds to negative 6. Now 1 and 5 don't do that, but negative 1 and negative 5, when you add them together, give you negative 6. So now I'm going to rewrite the inside of my equation using those two numbers. So what we get on the inside is x squared minus 1x minus 5x plus 5. And if we multiply this 2x back out and add everything together, we will still have 2x cubed minus 12x squared plus 10x. But from here, we can now group our like terms, and we can begin our factoring by group. I'm going to let you guys work out how you would factor that out, and then I will show you my work. So we have our x squared minus 1x in our parentheses on one side, and we have our negative 5x plus 5 on the other side. And we want to make sure that we take something out that's going to leave these insides matching. So we take our x from our left side, because that's the only term that I see that matches both terms. So leaves us with x minus 1. And if we take a negative 5 out, we are left with x minus 1 on the inside. Then we can group these, and we'll have x minus 5, x minus 1. But we're not done, because we have to bring our 2x back down. Now, if we want to check our answers, we're going to have to distribute that 2x into our x minus 5 and then multiply whatever we get by x minus 1. So I'm going to go ahead and do that now, and I'm going to give you guys time to do that on your own, and we can come back and compare. Okay, when we distribute our 2x, we get 2x squared minus 10x. And then we're going to multiply that by x minus 1 in parentheses. So when we distribute, we will get a 2x cubed minus 10x squared minus x squared plus 10x. And that is going to simplify to give us 2x cubed minus 12x squared plus 10x, which was our original answer. So we know that we factored it properly. Now let's do example 8. So for example 8, I see that I can take a 2 out, but I can also take that negative out, which would eliminate a lot of problems for us. So I'm going to take that negative 2 out first as my greatest common factor. I'm going to let you guys take that out and rewrite your equation, and we will meet back up. Okay, so I went ahead and did example 8 for us so that we could save some time. Feel free to look over it and make sure that I did everything right and work through it on your own. So when we're talking about finding the roots or the zeros or the x-intercepts of a trinomial, we are looking for these places where the x-axis is crossed by our graph. So if we take this example, y equals x plus 1, x plus 4, x minus 1, and we look at our graph, we can see that right here it crosses, right here it crosses, and right here it crosses. And those will be our x-intercepts. The other method for finding that is to set all of the factors in our equation equal to 0. So if we take x plus 1, which is a factor because it's being multiplied, x plus 4, it is being multiplied, and x minus 1, and we set them all equal to 0, and solve for x, we'll get our zeros. So we can subtract 1 from both sides on this one, subtract 4 from both sides on this one, and add 1 on both sides on this one. So this is going to give us x is equal to negative 1. This is going to give us x is equal to negative 4. This is going to give us x is equal to 1. And those are our zeros. And the zeros and the factors are the solutions to the factors, and the zeros and the roots are all the same thing. So if we ask for one of those things, there is a method for finding it, either in the graph or by setting the factors equal to 0 and solving. So let's put it together. So what are the zeros of this graph? Well, if we look at it, we can see pretty clearly that this is where our zeros are going to be. But because the graph doesn't have numbers between 0 and 5, we can't tell exactly what those points are going to look like. But if we look at the function, y equals x squared minus x minus 12, which is a picture, that graph is a picture of, and we set those zeros equal to the factors, we will find our answer. So first we need to factor our equation here. So when we factor and look for our greatest common factor, we see that x squared minus x minus 12 don't really share anything, so our greatest common factor is probably going to be 1. The next thing we're going to do is do our ACB tree, and our A is 1, it's hiding right there. Our B is negative 1, and our C is negative 12. So our A times our C is going to give us negative 12. And we're going to look for factors of negative 12 that add to B. And remember, our B is negative 1. So the factors of 12, as we've done before, are 1 and 12, 2 and 6, 3 and 4. And we're looking for one that adds to negative 1. And I know that if I make this 4 negative, this will multiply to a negative 12. And this will add to a negative 1. So 3 and 4 are the ones that we are looking for. We're going to rewrite our equation as x squared plus 3x minus 4x minus 12. I'm going to let you guys group your like terms, and then I will meet back. Okay, so we have our x squared plus 3x plus our negative 4x minus 12. And we're going to draw something out so that the insides stay the same, and then we can group. I'm going to give you guys a few seconds to do that, and then I will meet back up. So once I take my x out of the left side and a negative 4 on the right side, I'm left with x times x plus 3 minus 4 times x plus 3, which is what we wanted. So now we can group our terms. X minus 4 times x plus 3. And now, to get our zeros, we're going to have to set those equal to 0. So I'm going to set x minus 4 equals to 0. I'm going to set x plus 3 equals to 0. And I'm going to solve for those. I'm going to let you guys solve those, and then I will show my answers. And after we isolate our x on one side, we're going to find that x is equal to 4 and x is equal to negative 3. And those will be our zeros. Alright guys, so for our last two examples, we're going to work out our example 10 and our example 11. I am going to let you guys work through the steps, and I will reveal them intermittently. So we can see that our example 10 is already factored, so I'm just going to set those factors equal to 0 to find the zeros of the function. I'm going to solve for x minus 2, x plus 4, and x minus 20 to get my answers. And once we solve for these, we're going to get x equals 2, x equals negative 4, and x equals 20. Those will be our zeros. For example 11, we're going to have to work it out ourselves. I'm looking at 12x, 75x, and 168, and I see that they all share a multiple of 3. Once I factor out my 3, I'm left with 4x squared minus 25x minus 56. Now I can do my ACB tree. I'm going to label my A, my B, and my C. So we're going to have 4 times negative 56, which is equal to 224, negative 224, and I want the factors of 224 that add up to negative 25. I'm going to let you guys work on that, and we'll figure it out together in a second. And after we work it out for a little bit, the factors I came up with were 2 and negative 112, 4 and negative 56, and 7 and negative 32. And if we add 7 and negative 32 together, we get negative 25. So that will be the pair that we use. So now I'm going to rewrite my equation using my two smaller pieces. Okay, so now that I have my 3 times 4x squared minus 32x plus 7x minus 56, I can isolate these two sets. And remember, we're going to try to find something that's going to leave them even on the inside. I'm going to let you guys work it out, and then I'll meet you back. Okay, if I take a 4x out of the left side, I'll be left with x minus 8. And if I take a 7 out of the right side, I'll be left with x minus 8, which is what we want. Now we can group them. We'll have a 4x plus 7 times an x plus 8. And we have to remember to bring our 3 down and plug it in outside. Now we just have to set these equal to 0 and solve for them in order to find our answers. And when we solve 4x plus 7 is going to give us x is equal to negative 7/4, and x minus 8 is going to be equal to x is equal to 8, and 3 is equal to 0 isn't going to give us anything, so we're not going to use that as a 0. I hope you enjoyed this video, and if you need help or anything else, I will be there to help you in class. I look forward to seeing you. Have a good night.